Alright, hello everybody and welcome back to another Fix-It video, and this time we're going to be working on this little food processor that I got. And yes, when I say little, it really is little. Let me just zoom out for you, and yep, this is it. This is just a little guy. I think it's such a cute little food processor. I got it off of Craigslist. Somebody was giving it away because it didn't work, so it was free. I actually had no idea how small it was. It's funny, my sister-in-law picked it up for me because it was right by where she lives, and she just texts me and says, I got it. It's really, really small. And that's true, but hey, that's cool. It was free. It'll be fun to try to experiment and see if we can get this thing running again, and then use it for like just little things in the kitchen, not anything major. So first off, let's try to figure this out here. Where's my plug? So plug it in. Actually, let's unplug it for a minute. Let's before I mess with it too much, let's just take out the blade. I don't want to mess with the blade. It should, in theory, I would think, work like this. It is an Oster brand or Oster brand. It is the, trying to see if there's a model number in case anybody was curious. I don't see a model number. Yeah, I can't see a model number, but I'm sure it's on there somewhere. But either way, here we go, and let's see, it is plugged in. And there's a low and a high setting. Nothing. As expected, it was sold as, or it was given away as not functional, just in case there's some sensor, something like that in here. Let's put this on and all together. Oh yeah, because there actually might be, you know what, it might need the lid on, because there's probably a mechanism. Interesting. There's probably a switch in here where the lid connects to, so that it doesn't turn it on when you have like your fingers in there. I was trying to turn it on one direction. It does not. The lid does not want to slide around, actually, though, which is interesting. So there's grooves on the lid, you can see. The grooves, or the little tabs, I should say. The tabs look like it should slot right into here, where there's some type of switch in here. And it's not going past it, and it's not locking into place. I don't know if that's because, is the switch, oh, okay. The switch was kind of locked in the closed position. I was able to just push it back. Let's see what happens now. No, don't want that. Put this first. This on. Try it without the blade. There we go. So now it actually slid in. Whether you saw that or not, it actually spun all the way around this time. So I think the switch had just got knocked out of place, but let's see if that changed anything. No, it didn't. It could be because there's not power getting to this. It could be because that switch, the fact that it was knocked out, is actually not making the contacts it's supposed to make. Either way, it looks like we're going to have to open this thing up to find out. So let's see. Some standard Phillips screwdrivers. Much longer screws than I thought that was going to be. Yeah. Okay. Bottom just pops off. There's grease, it appears, in there. I thought it was actually like food, stuck on food, but I think it's just grease, so nothing big. There's a bunch of, so there's gears here that obviously spin everything. Those seem to rotate fine. So that seems like it's fine. I'm sure it's just a problem with the power getting here. Now, I was not expecting to run into a bunch of gears though on this side. How do I get these out without like completely disassembling them? So I can just get to the switch and such, whereas I really want to go the electronic components of this. I mean, I can see the board and such down here. Okay, it seems like this whole mechanism might be able to just lift out. I gotta be careful because there are cords. But I'm assuming in order to lift out the mechanism, I will need to somehow separate this from back here. And it does look like it's held in. So I can tell, okay, I can tell this screw and this screw right here are holding this base on. I'm sure there's more up here. It's probably this screw and this screw also holding this base on. But I'm positive I'm going to run into problems with this unless this pulls off. I'm not really sure, so let's just remove these and see what happens. Can't really break something anymore that's already not working at all. I mean, I guess that's not true. I guess you easily could, but what does it really affect? Okay, then. That was not what I expected. So when I unscrewed the second screw, something was being held on down here into position. You can see it like rattling around in there now. A whole component that, I don't know if you can actually see that rattling around in there. I think you can. It's going to be a pain to get back on if I don't get the rest of this out. So I guess we're going deeper. It appears that this probably was not meant to come out in the way that I just took it apart. Okay, it's still definitely not free from what I've just done. I mean, there's these, oh gosh. I was going to say, oh no, it's going to be terrible. There's these three screws here, here, and here I can see, but there's also one, let's see if there's an angle up here that I would just never be able to get to. So maybe this is not the correct way into this machine. I don't see how else you would do that, though. You can see down in there, all the way at the bottom, there's a board down here, which is where I'm trying to get to. I just don't know how to do that. There's a clip ring here. There's no other. Yeah, there are no other ways into this board. I'll be honest, I thought this was going to be a pretty easy diagnosis, at least. Whether a fix or not, I wasn't sure, depending on what was wrong with it. But I thought I'd be able to easily get to the places I needed to get to in here and make that determination. This is slightly more complex than I anticipated here. Yeah, now the one major thing holding this on is this screw that I can't get to. I do think I have to unclip this. Let's see how well you can see that. There's a clamp here. I can't tell in the lighting. That I need to get off. Hopefully with these tweezers I'll be able to get it off to remove this gear. do not have the proper tools to do this. Let's see if we can use some tweezers. Come on. Yes. It has been removed, but it flew across the room that way, hit the wall. I think it hit the ceiling. I heard it bounce under me. Amazing. Amazing. There it is. I found it. Whew. Okay. I did not expect that to happen. Alright, so that wheel comes, or that gear comes off. Now, here's the problem. Does this other gear come off? It raises up and down. I think this gear might be able to spin off, actually. It's actually got a nut. And if I try to pull it, you can see that this moves up and down. So I think if I lock this in and try to spin, it might actually be able to back off the nut here. I don't have any pliers up here right now, though. Okay, let's see if these will work. There we go. There we go. That did loosen up. Kind of feels weird because it's almost like it's going to righty-loosey, but I'm sure it's just, there we go, the way it is designed. So now I can get to that screw that I was talking about. Which should now lift out this whole assembly. Exactly what I needed. Ooh, something else just fell out of my hand though. A washer. Okay, there's a washer that goes on here as well. That fell out. And one of those screws fell out, but that's fine. Okay, so I've gotten to the bottom of this. Probably need to put this back on before I move forward, because this is what that piece that fell down. And it clearly was not supposed to come off. It's supposed to be a guide. So let's get this back on. Okay, there we go. So now let's take a look here at what we got. And it looks like we have so this is a diode relay to convert AC to DC going on right here. So this thing runs off of DC. What I can quickly do, let's get the, see if I can get this somewhere where you can actually see it. Let's put it on the voltage DC. Then, hopefully that's somewhere where you can see. And we can plug this back in, being very careful. And just check across here. And we get nothing. We do get nothing, however, it also comes, oh no, I was going to say it comes from the board first, or the switches first, and then to here, but that is untrue. This should be straight down. Let me check. Maybe that's an, Oh no, that's the. I'm going from. Okay. I was connected from the wrong things. These are actually. This is gonna be a continuity. There we go. I have to relook at the circuit. This should be continuous through a diode. I don't know if you can see the numbers changing. It is it's not a direct circuit, but it actually, well, yeah, it actually shouldn't be a direct circuit because this is making sure you can't get from there. Hold on. Ground. That's your output in, around there. That's your output. This should be your output. Hold on. I'm still plugged in, so be careful. If I... Here, first to check to make sure I'm getting... Let me make sure my AC voltage coming in is correct. So the AC voltage, the two power leads are connected between this, what's in this cap here, and over here. So if I shove this in here, we should get 120 volts coming in here. There we go, 120 volts coming in here. I don't know if you can see that on this. Get it inside a little bit more. There we go, 120 volts coming in. So that means my leads are fine. This is fine. It gets to here. I'm getting one leg of my AC voltage coming up here and going straight up to the buttons. The other leg is coming in here into this bridge rectifier in order to turn it into DC voltage. So, knowing that, let's unplug this. And I'm going to have to get this board and button set out of here to do further diagnosis, because that's got to be where my problem lies. Four screws in. There we go. Okay, that is out. The switches apparently stay in as a separate module here. Let's take a look at how these work. Not 100% certain how this lid close switch works. It just seems to go left and right. I mean, which makes sense, but it doesn't, like, it's not metal. There's no connections that it's making to anything. So what is it actually triggering here? Okay, so I think I figured this out a little bit. This white piece here does not actually make any contacts with anything directly. Like, there's no metal on it that makes any contact. There is, however, a protruding edge right here. Let me see if I can zoom in to show you. There's a protruding edge right here at the top of this thing. And notice I'm holding right now the lid on and showing how when I turn the lid, I don't know if you can see the plastic piece come in there. It grabs the catch and moves this to the side. And there we go. See, it moves this back and forth in order to engage with a switch that seems to be, let me take this apart, on this board right here that sits within, that sits back up in there. And the way that this board goes is it flips over like this and it goes, nope, sorry. It goes this direction into here. That's only important because what it does is that means these right here, let's see if I can get this thing to zoom. I hope that zoomed. These line up with the switches, or the buttons that are on the top. So these are little clicky buttons. This, however, is the safety mechanism, and you can see that this is another piece of metal that lifts up, and that switch that I was just showing, the white one, when you actually make the lid make contact, it's supposed to slide over and push this down, which closes this circuit to then allow the power to flow through this, electricity to flow through this, and therefore turn it on. And so my assumption is that this was not engaging, and that's the problem with this device. I don't see anything clearly, obviously wrong with it. I think it might have just come loose. Like I said, the switch originally, when we pulled this thing apart, the switch was really like loose and wonky in there, so I think it just kind of came out of place. But we're gonna clean this thing up anyway, and just use a little bit of IPA and wipe just to make sure that this is clean. Bend these into a position where I think that they're gonna make optimal contact, and then I'm gonna start putting this thing, well, I'm gonna test it first before we put it back together. I want to see how much voltage is actually coming through here as well. Judging by this, is it gonna have 120 volts DC running through this because of the way the bridge rectifier works? Let's actually find out. So if I trace this, it's going to be down here. No, this one. This contact here closes the circuit to that. There's also a diode. Closes the circuit to there. I'm assuming then that we'll have continuity from here to here, and that's how this works. I know it's a little blurry. Let's just zoom it back out, but let's see if that's true, because that's the only thing that makes sense with the way that that switch works. Yeah, so here to here does not have that has continuity. This does not, though. So how does that actually close this circuit? That is connected to here. So that's one of the leads. Connects over to this. It's really difficult to see the camera here, the lens finder, to make sure it's actually zoomed in appropriately. This is one of the leads, and this is one of the leads. Yes, those are connected together. This is connected through a switch. Oh, is it connected maybe up here? Oh, okay, okay. Maybe it's connected. Let me see. Let's get this out of the way. Maybe the continuity is between here and here. I don't see how pushing this down is helpful at all. Well, pushing this down actually doesn't even give a good contact. Where does this go? I don't quite understand what the safety switch is actually connecting. If I close both the safety switch as well as just one of these buttons, it's not making the motor move. Which one would think would happen? Well, in fact, the motor's not even... Hold on. It would be this motor that's going to be... Oh, you guys can't see that. Let me zoom. So it would be this motor right here is what we would expect to start spinning, because that's what would in turn drive all of this at the end of the day. We know we got 120 volts coming to the board. We are on, there's no like switch. Just for the sake of testing, what happens if I direct wire this up to run? Okay, so at this point what I'm doing is bypassing the circuit board and trying to see what happens if I make it so that the 120 volts is direct feeding that motor. Clearly not good. All right, so it's been a few days of experimentation, and I think I might have gotten somewhere. And I'll show you what I did was I was experimenting with just completely bypassing the board and the switches, and I fed the voltage directly into the circuit where the red and the black wires are right here, the 120 volts AC, which seems like what happens at this board is it just, once you hit the right buttons, the combination of buttons, it will pass the voltage on through to the motor. So I didn't think there'd be anything crazy with that, but I did that and it started smoking. So I stopped, re-looked at it, said, I don't understand what's going on. I ended up trying to put the voltage directly to the motor itself, which was a very stupid idea because it started smoking a lot then. And I looked at the motor, and of course it did, because this motor is, it says right on it, I don't know if you can see that, it's 120 volts DC, is a DC 120 volt, and I fed it 120 volt AC directly to the motor. So who knows if this motor is still good or not. But it had me continue to experiment, and what I was realizing is if I put my meter into continuity mode and go across each of these diodes, there is a direct connection between all of these four diodes that are here, which is the bridge rectifier, which is going to take the 120 volt AC and turn it into 120 volt DC. Even if I switch the leads, it still has a path through. And I was always under the impression that using a multimeter, having one of your probes starting at the beginning of the diode and the other probe on the end of the diode where the current would go, or the voltage would go through, one way it would work and give you a very low resistance, and the other way it would be an open circuit. That's how diodes work. It only lets the electricity pass one direction. So I realized that, and I was like, I don't know if it's my meter that doesn't let me do the right kind of, if it doesn't work like that, my particular meter, or if it's the diodes themselves are actually all bad. So I bought a package of diodes. I didn't have any diodes, so I bought diodes, and I had to wait a couple days for them to come in. And I've gotten some diodes that I set up in a bridge rectifier fashion, even so I had tested individually. But if you can see, if I test just one of these one direction, I get no reading. And if I test switching my probes and go the other direction across the diode, I get a much lower resistance value it's not quite an open, or it's not quite a completely closed circuit, but it's a 600, 600 ohm resistance, which is fine for a diode. So I've set it up into a bridge rectifier, and I think what I just need to do is replace this circuit with this bridge rectifier and see what happens. Again, I might have to go through and directly feed the 120 volt AC to the bridge rectifier to then step it down to it doesn't really step it down, to change it to DC and see if this thing works, not directly to the motor. Because like I said, the motor could be bad. I don't know. But all the experimentation I've done leads me to believe it's the bridge rectifier that has gone bad, because there's nothing else on this board really. It's just there's a diode on this board and there's some wires and some switches. That's all this board does, is it's basically sends electricity through based on what switch you've hit. So let's try to get this out of here. Okay. Should be done with soldering. Let's see now. I remember how all this works. Yeah, this ran across this. Okay. So it's basically, I'm going to plug it in, I'm going to press down on this for the safety, and then one of these for the speed controls. And that should get this thing spinning, if that was the problem. So let's find out. Okay, we're plugged in. Safety switch. No. What am I missing? Could be the motor. The motor could be dead. Remember. So let's just run DC voltage. That should be giving me a DC voltage reading if we make a connection of any type. And we've got nothing. If I switch to AC voltage just to see. Nope. So it's not a problem with that. Let's make sure we have 120 volts coming. Well, it wouldn't be coming in to here because something's wrong with the circuit on the board. So what we can do is, just to see if the bridge rectifier piece worked, let's disconnect this power cable, and I'm going to use this power cable, which is just literally an end with two opens on it. This is a little bit dangerous. This is kind of how I made the motor smoke in the first place. But if I just connect these temporarily to where this circuit is. So what I've done is I've put one end to where one of the wires is coming out of here to the bridge rectifier, the other end to the other. I can plug this in, and in theory it should just step it down to DC and the motor should start to spin automatically because I'm not connected to anything else. It worked. So the motor still spins. That means my bridge rectifier is now functioning. I'm unplugged. So that means right now then, there's a problem somewhere on this board. It could just be with cleaning. Where would these... It could be this diode down here as well. I couldn't test this diode that's on this board. Let me, so let's check. Well, if it was open though, that'd be interesting. So let's see. 600 ohm resistance that way. The other direction, nothing. So that diode is actually functioning appropriately, unlike what was happening on this board. So where then is the problem with this circuit? So the rectifier was definitely an issue, because I tried that exact same thing that I just did prior with the old rectifier on there, and it started smoking. And I'm sure that's because the diodes were, they were connected somehow together and not functioning appropriately, and it was letting the current pass straight through to itself. That doesn't really make sense, but you get what I mean. So let's just let's unscrew this board then. Had to switch batteries real quick. Okay, with this the safety switch, let me see if I can zoom in here. This is the switch right here, the pressure switch, that the safety mechanism on the lid will connect if you've got the lid screwed on appropriately. So this should close, which you can hear it. But the thing is that it doesn't go anywhere. Like, it doesn't, I'm not sure where the other end of, this is the end of the hole. So this is where the power comes in. It would connect and go through here, but I don't know where that goes. In fact, I don't know where any of this stuff goes. Like, even the connections on the low and the high speed. Yeah, these are the low and the high speed. They don't go anywhere. They just, I guess they just complete the circuit. Because right now, well, no, so this one, I honestly am, this is such a simple board, and I am stumped at it. And I've taken many electrical engineering courses. I have a computer engineering degree, which is essentially like electrical engineering. Granted, I got that 18 years ago, and I don't work in that field anymore. So it's been a long time since I've utilized this knowledge, but I gotta figure this out with the continuity here. So if let's make sure this works. This and this. Oh, I think that was the wrong. I mean, so this, it works. It's not the greatest, but it works nonetheless. So when is it ever gonna... Low speed works fine. Okay, they're making the connections at least. Whether clearly something's not working fine. So the switches all work. So it's not a switch issue. But let's follow this in. So it comes in from here. Yeah, it goes, power inputs into this part of the board here. Power inputs here. Let's trace this. You close this switch. I don't know where it goes from there. Like, that's the thing, is I can't quite figure out what connection that ends up making. So there's no traces. So where am I expecting this to go? Up to here, probably? And that doesn't do anything. No. And I think that's part of the problem, is based on these switches, it doesn't go anywhere. So you make a connection here. What goes back to the output? It would be this one. Yeah, this one. So from here, goes back to the output of the motor, or the input of the motor. And it's whether it's a diode. What is that diode doing? I can't tell where this is connected to. To make sure my polarity is correct to get through this diode. Because even from this, if I go here to here, that's nothing. So if I switch my probes, that should, yeah, that's my reading through the diode, which is fine. I mean, it's not a multi-layer board. I don't think it is, at least. You know, it's very strange. It's as if, just staring at this board, it's as if you go into low speed by going through this diode, and it basically takes the voltage drop and utilizes that. Let's see if you can zoom in there. It utilizes the voltage drop from the diode to give it a lower speed. Whereas if you're in high speed, it's just a straight connection through. That's what I'm seeing on this. But I still don't know how to get from the input, the AC input to the AC output of this board. So I don't know how to get from one wire to the other wire, essentially, is the problem. I just don't see a connection. It is baffling. Those are down. I got excited for a second. Let's check. This is, okay. Safety switch makes everything start working through this via. Can you even see that? Yeah. This via right here is the other end of the safety switch. So something has to be connected to here. This has to go somewhere. So best guess into what this would be is that there's something supposed to be connected from here, the other end of the safety switch, to this plane that's between the low and the high button. So then you got power going up here, and then when you close one of these switches, the power gets sent down either through the diode for a voltage drop for low, or it goes straight across here for high. I think that's, yeah, because then it traces back down and around and goes out to the output. Otherwise, if you press the low, it goes down through this diode, which connects between these two, and then it goes to the output. So the only thing that's missing is that there's missing a connection between this and this. But how? How is that connection missing? Is there some other way that things get connected just in like here? The switches literally are just pushing. Ooh, there's a broken post. I don't know if you can see in there when I push up, but there is a broken post here that otherwise, I mean, it looks very similar on the other side of it though, so I can't see what that post would be doing. But if I'm gonna, I mean, let's look at this for a second and say, you know, go on like this. Broken post is on this side. I don't see what it would do. So I really don't understand. I will be completely honest. I don't understand. You know what I'm going to do though? Look at my diode kit. I'm going to use one of the same diodes that I used for the bridge rectifier because it's the appropriate voltage and current. So I didn't have the exact same numbers, but I'm going to put a diode between the end of the safety switch and up here to this high-low plane, which is all connected. I don't want to just bridge it with a wire. This way will, prevent a short if there's, any potential shorts, reverse voltage, or anything. It'll prevent that from causing a problem. And I will put this on. It'll make my connection that I want it to make with some safety involved in it. I need to make sure it doesn't actually touch the other wire though. That would be bad. Let me actually pull it up. Pull it up like that so that it can't do that. There we go. There we go. Let's solder this up. We're gonna solder this up and see what happens. I'm not 100% certain how much I'm gonna trust this device, because nothing broke off of it. It's not that something is broken. It's not that something is obviously damaged. It's not that there's even looks like a component is missing. It just looks like it's missing because that's what completes the circuit. There's no gap in the board. Guys up. Okay. This is going to be that's weird. Yeah. Plug this in gently. Okay, nothing happened. Good and expected. If I press down on the safety switch, again nothing happened. Good and expected. But if I press down on the safety switch and a low or a high, that's it. I mean, I'm gonna unplug it. I don't understand if this thing ever did actually work, which I'm just taking the word for it from the people that I got it from, that it worked. Because they actually said it worked intermittently is what their response was. I couldn't ever get it to work at all. I can't see how this would have worked at all without that connection unless there's something super obvious that I'm missing. But given that it's functional, I've traced it all back and now understand why it wasn't working, at least from what I can, the information that I have that I've seen why it wasn't working is because of their bridge rectifier was bad, as well as the object or there was no connection between the planes to actually send power to the bridge rectifier. Yeah, I'm just going to put it back together and we're going to see what happens here. All right, back together. Moment of truth. Let's plug it in and ensure that nothing's happening. Good. As it should be. I'm not putting the blade in for now. Put this in, so nothing should happen. Once I put this lid on, though, something should happen, and it's not. Wait, let's check out the switch. Put in the right thing, right? Yep. The switch does not feel like it's making contact that it's supposed to be making with the board. Okay, I took it all back apart. I fiddled with the button, the switch. I bent it a little bit to make it have better contact. I kind of tested this as I went through by forcing the switch manually over with a pair of pair of tweezers, and it worked throughout the process. So this is the last time I'm going to put this together. So let's just hope it works. So on nothing, or it's plugged in, I mean nothing. It's as expected. Let's put this on. Switches making contact. Ugh. So it works. It doesn't sound good. I mean, maybe that's what it's supposed to sound like. I have no idea. Let's actually put the blade in. This might just be based on, I might take the bottom off one more time, because this might just be the gears not sitting exactly right, and that might be a quick fix from the bottom. But no matter what happens with this, I have gotten the electronic components of this functional again, which is just still kind of baffling how it was put together without a connection between the safety switch and where that power needed to go. I don't understand how this thing ever worked, but judging by this table, there's clearly a lot of debris and food debris and stuff that was in here, so it did work at some point, I'm assuming. Be pretty elaborate for somebody to be like, hey, this thing never worked, let's make it look like it worked. Put a bunch of food in there. That'll get them. This is, I mean, the gears don't seem to be sticking at all. Make sure this one's tight. Maybe it needs to twist on more. It's as much as it twists on. It seems smooth in here. Motor's actually a little jumpy, but I kind of have a feeling that's how it's supposed to be. I mean, take the blade out here. Let's put this back on. I just think that's how it's supposed to, it must be how it's supposed to be, because there's nothing else there's nothing that's bouncing around in any funny way. The stuff's all just spinning normally. I can make sure that, you know, this clip is on the right spot. There are these washers under here that are, you know, making this thing a little bit loose, but I don't think that's what's making the noise. Yeah, I mean, I think that's just how it's supposed to be. Having never worked, I heard this thing work in the first place before, like I don't know, you know, what it originally sounded like to know if this is potentially a problem. I have no idea. So I'm just gonna go for it with this, put this back together. Let's see it working in all of its loud motor glory. They call it a very long and complicated fix for a very small piece of kitchen equipment. Right. Here we go. All back together. Technically works. I'll be honest, I don't hear a difference between the low and the high speed. So my thought on using the diode as a voltage drop may or may not be correct. I'm not really sure. But long story short, this thing is now technically functional again. I don't know how much I trust this thing. It was more of just a thought, experiment to see if we could get this thing working again, which we did successfully. Keeping in mind the only two things I ended up having to do to this thing at the end of the day were create a new bridge rectifier, and then I had to make a connection from the safety switch in order to allow the electricity to actually flow by adding another diode in there. Where it looked like there was nothing. There was no other component. There was nothing that looked like it was missing. There's nothing that looked like it was broken. I have no idea what was happening before to make this thing work intermittently as they stated it did. But it is now functional. I don't know if I'll ever use it because I don't really trust it and it sounds really loud and obnoxious, but it has been fixed. Thanks for coming along on the journey and watching, and until next time.